I have opened the data for BMI, waist circumference and blood glucose, and this is just for the women. It's not the exact data from the paper, but it should give us some similar graphs. And what we're looking at here is I've just got a couple of images taken out of the paper. One for body mass index with waist circumference, and we're going to look at the women, and then also waist circumference versus fasting blood glucose level. So if we just take a look at making sure we understand what's going on with the scatter plots, let's try and draw these first. I've actually just cut and pasted these pictures into the output file for SPSS. I didn't realise I could do that. That's quite nice. Saves me having a million different windows open when I'm trying to record videos. So let's go into Chart Builder. Let me reset that so we do it fresh. So we're going to use a scatter plot. We're just going to start with a simple one. We're going to follow what the paper did, BMI and waist circumference. So these are two measures on a person which we would expect would be correlated, probably quite highly correlated, but it's not a cause and effect relationship. The two just go together. So although the paper has chosen to do it this way around, there wouldn't be anything incorrect about switching the axes around in this case. So we can see if we're able to interpret this graph, each dot represents a person. So for this person here, we could read off their BMI from the x-axis by just going all the way down, and they've got a BMI of about, I don't know, what, 52 or something? And then their waist circumference is around 148 maybe. So we can read off the measurements for a person in that way. And if we're talking about the correlation, it's as body mass index is increasing, we can see that waist circumference is also going up. So we've got this, if this is low, then waist circumference is low, so we've got the low-low, high-high relationship. So this is going to be a positive correlation, and the dots are quite tight together, they're not spread out a lot, so this is going to be quite a high correlation for this relationship here. Let's have a look at the other graph, and that was for waist circumference versus fasting blood glucose level. What am I in at? Chart Builder. So we're going to put waist circumference on the x-axis now and have a look at the relationship with blood glucose level. And in this case, this is another one where we would think that the two might be related, but they're both caused by some other variables to do with diet. It's not that one causes the other. But it's possible that in a clinical situation you might want to use waist circumference as a proxy measure for blood glucose. So in that case, if you were trying to use one measurement to predict another, even though it doesn't cause the other, you would put that as the independent variable on the x-axis, and the one that you're trying to predict would normally go on the y-axis. So we'll do them that way around. Now it does look like we have this trend upwards, but here you can see that the dots are way more scattered about. So we are going to expect a positive correlation here, but it won't be as strong. So it's not going to be close to 1, it's going to be closer to 0. So let's have a look at running the correlation for these three variables. So I'm going to go to Analyze, Correlate, and we're going to use just the first option for bivariate. So bivariate just means two variables. So even if you give it lots of variables, it will just calculate the correlation for two variables at a time. So I'm actually going to pop all three in. If I can. Why is it not selecting all three? We're going to leave this at Pearson correlation. Sure, flag the significant correlations there. So we get this little 2x2 table, which you might reduce down into sort of a correlation matrix. So body mass index correlating with body mass index, well obviously that's the same measurement, so it has to be perfectly correlated at 1. We're not really interested in that, that's just an artefact of the way that it spits out this table. The correlation between body mass index and waist circumference is very high, 0.954. So that relates to this graph here. So the dots are really close together. So it's a very, very strong correlation. So the correlation is not a measure of the slope of the line at all. It's just how tightly related the two measurements are. So that's a very strong correlation. And then we've got body mass index with blood glucose is also significant, and that's moderate, that's pretty good, but it's not as high as with waist circumference. And we haven't done a graph of this, we did the waist circumference with blood glucose. So then if we look at waist circumference, we have the correlation with body mass index, which is the same obviously either way you do it, and we can see that the correlation between waist circumference and blood glucose, I need to get rid of that yellow box, is slightly higher than between body mass index and blood glucose. So based on this one study, if you had to get a really quick measure of indication of blood glucose, and you couldn't measure your blood glucose for some reason, then it would suggest that perhaps the waist circumference is better, only very slightly though, than BMI. So it's got a slightly higher correlation. But still far from perfect. That would only be called a moderate correlation, I think, rather than a strong one. So, well, I'm just reading through my questions on my other screen. So we have that the waist circumference is more strongly correlated with blood glucose and body mass index. Is the relationship strong enough that in a clinical setting you could reliably use one of these measurements rather than taking the fasting blood glucose test? I'm going to say no. I'm not a clinician, but to me, I'm not confident that that would be strong enough that you could forego the test completely. But perhaps if you wanted to do some kind of questionnaire or give somebody an indication of their risk for certain things, that this might be something that you look at. So let's have a look at if we were going to try and predict, if we were going to try and predict, what have I got here? Waist circumference from BMI. Sure, let's do that, although I can't see why we would. Sorry, I'm just reading through my notes. Yes, I've got to do it both just for practice. So let's have a look at running the regression equation for both of these graphs. Now, if we double click onto the graph, we can actually pop the regression equation straight onto it because we're just looking at a simple linear regression. So that's under add fit line at total. So fit line just means the straight line which fits the best. That's a mathematical calculation that's done basically by averaging out all the dots. I mean, it's obviously a bit more complicated than that, but essentially that's what it's doing. Now, it'll pop up automatically as it says linear, and that means a straight line. It's possible that in some situations a curved line might be more appropriate, but in this one I don't think it is. So we could use simple linear regression because a straight line seems reasonable. As with anything, this is not 100% accurate. We would put a confidence interval on that. Often people publish these without confidence intervals, but I think it's a good line to put them on as a measure of how sure we are that we have captured the true relationship. And in this case, it's fairly tight because the dots are all quite close together. And then this is our actual regression equation here. I find it incredibly frustrating that this is so difficult to manoeuvre in SPSS. No, I don't want to move that. It pops the equation right on top of the line, and then it is really difficult to move. I'd like to pop it over into an empty box, and I think sometimes I get so frustrated with this, I just delete it. Oh, hold on, is it going to move? It won't go where I want it to go. It's like the line is a magnet and I can only take it so far away before it stops. Right. Oh, and it didn't move it anyway. So, no, it doesn't want to move. I would like to change the font size though. Anyway, so we'll have to leave that there in small font. I'm sure you can change that. Probably what I would do is just delete it and add an annotation or subtitle or something and put it somewhere easier to read. So we've got y is equal to 46.51 plus 1.92 times x. So our y variable is the waist circumference and our x variable is the body mass index. So if we were trying to predict waist circumference from body mass index, that would be our predicted waist circumference is equal to 46.51 plus 1.92 times your body mass index, and you could put that predicted value in. The R squared value is a measure of how much variation in waist circumference can we explain with body mass index, and this is very high, so it's 0.91, which would be 91%. So that's saying we can explain 91% of the variation in waist circumference with body mass index. So that's a really close relationship. We can run that analysis. So I'm going to go to Analyze and Regression and Linear. And you can see there's loads of options here. So regression is just it's a really big family of techniques, and we're going to look more at it next week. And the simplest form is fitting a straight line. So in this case, we're treating waist circumference as the dependent variable and BMI as the independent. So we're looking at the relationship between the two, even though one is not really the cause of the other, they're just associated variables. No, I can never remember where anything is. Save. Let's save the predicted value, the unstandardized residual value, and the standardized residual value. Okay. So we've got quite a lot going on here. So we have our R, which is our correlation, our R squared. So you can type in the correlation on your calculator and press the square button and you should get the R squared value. We have an adjusted R squared value. Now this is an adjustment based on the sample size and the number of variables you're trying to put into the one model. So this is a better measure to use, but it's a little bit more complicated to explain where it comes from. So in terms of this course, I'm quite happy for you just to use the R squared value. If you go on to do any more advanced statistics, you might want to get your head around using the adjusted R squared. Even if you can't calculate it, it's important to know that this is probably a better measure of how much variance we can explain, just because it does take account of some other things, not just the correlation. The ANOVA gives us an overall statistic for if we have a relationship there. So it's an overall test for the whole model. With a simple model, it doesn't seem to make much sense to have two versions of this, just because you're really only testing BMI anyway. But when we get onto slightly larger models next week, you'll see that it is quite handy to have the ANOVA table as well as the coefficients table. So these are the coefficients that we could use if we were actually writing out the equation. So these will most likely match up to what happened on the graph. Occasionally you can get something slightly different, just because there are a couple of circumstances where it does do slightly different things on the graphs. But in this case, that looks the same. So we've got a constant value of 46.5 and a BMI of coefficient of 1.9. So if we go back up to our equation, 46.5 and 1.92. So that's the same equation there. The test statistic, this is a t-test, and its testing is this coefficient equal to 0. We've got very strong evidence that the constant value is not 0, and therefore we would keep that in our regression model. And the next line is testing is the slope, which is the relationship between BMI and waist circumference, is that equal to 0? And we've got very strong evidence that it's not. So it's saying that both of these are significant. We usually care less about the constant value. We care more about the slope value, because that's the relationship of interest. Now, if we have a look at our data, I did ask it to save the predicted values, the residuals, and the standardized residuals. So we have here the waist circumference for this person was 73, based on the equation for BMI, they would have been predicted to have a waist circumference of 82. So the difference between those two measurements is the error or the residual, and this can be standardised onto a standard normal distribution, which we would expect to lie between about -3 and 3. You can go back to that week and review that material. And this is quite helpful because it gives us a way of knowing if anyone was unusual. So that would be an outlier might have a very large residual. It's gone a bit funny. So I don't think, we didn't have any really big outliers, but obviously this person is much further away from the regression lines than the other one, so that person would most likely have a larger residual. Now, in terms of the assumptions for this linear regression model, we're assuming that a straight line is a sensible relationship to fit, and in this case that looks fine, it does look straight. We would be assuming that the errors or the residuals are approximately normal with no outliers or no strong outliers, and we would be also assuming that the distance of the points from this line or the variation in the errors is similar up the length of the line, and that looks okay. So we can do a graph of the residuals to check for normality. I'm going to reset this and just do a histogram. Now you can use the raw residuals or the standardised residuals. You'll get the same shape, but the standardised ones can be a little bit easier to interpret just because it's easy to tell if something's large or not. So we've got, it's a tiny bit skewed, but it's looking okay. So we're going from -2 up to just over 3. So I'm going to say these are okay. And this would be that person here, that would be the one that was the furthest away from the regression line. So going back up to here, that would be that person there, I reckon. They seem to be the furthest away. So they're a little bit of an outlier, but it's only one of them and it's not too bad. So that would be all right. And actually we could probably do a box plot to see if they came out as an outlier. Yeah, just the one. So what I would encourage you to do is have a look at a regression model for the blood glucose from waist circumference and see if you can go through and do this residual check and have a look at the R² values. So that will be much lower for the blood glucose from the waist circumference because it was a much lower correlation to start with. So we will be explaining a lot less of the variation in blood glucose from waist circumference than we could for this one here.